In today's lesson, we're looking more at the geometry of 3D shapes to include volume and surface area. So, let's start with what IB calls a cuboid. It's a rectangular prism. As you may remember, the volume formula for a cuboid, well, I hope you do. Volume is length times width times height. And how would you find the surface area? Well, surface area is the area, the sum of the areas of each face. There's not really a formula. I know Tax and Star put a formula on the formula chart. There's not really. You find the area of that side, that side, that side, that side, and add them all up. Now here is a triangular prism, but it's still a prism. So this one, for the volume, you'd have the area of the base. Now in IB they just put A. This is the area of the base. And remember, which side is the base? Well, on this one, it'd be the area of that triangle times the height. And the height for this picture would be this, not this height. So be very careful. This would be the height of the prism. And you think of it as setting the figure on its base to figure out where the height is. Again, the surface area is the sum of the areas of the faces. Next is a cylinder. The volume of a cylinder, again, the area of the base times the height. But on a cylinder, the base is always a circle. So that would be pi r squared, area of the circle, times the height. Surface area of a cylinder. Does anybody remember that? Well, we have the two circles, the top and the bottom, so you have your two bases, plus that curved surface that's going around, so the lateral side. Now, if you unfolded that, when you broke it apart, think of a label coming off of a soup can. It's going to go around the circumference of the cylinder, and it's as tall as the height is. So here it is broken apart. This side would have been going all the way around that circle, so it's 2 pi r. And this side was the height. Now we have those two bases, and those are two circles at pi r squared. Be careful about just memorizing formulas or using formulas on this part. It's really more helpful to think logically about which sides. Sometimes, when you're asked to find the surface area of a cylinder, it may be that it's including both bases, and it may not be. Depends on the situation. Next figure, pyramid. Well, pyramids and cones are very much related to their cylinders and prisms. The volume formula is changed just a little bit. It's a third of what we had before. So it's a third of the area of the base times the height. And notice that the height is going to be that vertical height from the center of the base up to the top. It's got to be perpendicular to the ground. The surface area, well, gosh, it's the sum of the areas of the faces. On this one, you would have that base, and then you'd have each of those triangles. On a cone, the volume is 1/3 of that of our cylinder. So it's 1/3 of pi r squared h. These formulas for the volumes are on your formula chart, as is the area of this curved surface on the cone. So when we're thinking about the surface area, you have that base plus that lateral area, that lateral surface, the curved edge. Now on a cone, you only have one base, and that lateral surface, its area is found by using the formula pi r l. This is on your formula chart. The L is this slant height right here, going along the edge of the cone. The R, of course, is your radius. Oh, well, we'll fill in there too. Your height is there. Now, as for a sphere, the two formulas you'll need to use and are given to you. The volume is 4/3 pi r cubed, and our surface area is 4 pi r squared. So now let's practice applying them. On the next page, we have the radius of a cone is 12 centimeters, and the height is 16. So we're supposed to find the volume and surface area of the cone. So first things first, draw a picture. Radius goes from the center out, and that's 12. The height is 16. We're supposed to find volume and surface area. So if I were doing this on my test, I would start by pulling up my formula chart. And notice on your formula chart, all of these good things are here. The volume, it says, is 1/3 pi r squared h. Always show your formula. Then show what you plugged in. Now the itty-gritty little calculations, they're not so worried about. But they do want to see which formula you chose and that you plugged in the numbers in the right places. So I would do 1/3 times pi times 12 squared times 16. And we want to go 3 significant figures. So 1, 2, 3. That gives me 2,410 centimeters cubed. My units were centimeters, and volume would be cubed. For the surface area, we have the circle at the bottom. That's pi r squared, plus that curved surface. And the formula for that is pi r l. That is on your formula chart. Uh-oh. L is my slant height. I don't have that yet. Oh, but isn't the height perpendicular to the base, making that a right triangle? Oh, good old Pythagoras. 12 squared plus 16 squared equals L squared. So I would come over to the side somewhere and show that that's how I'm going to find L. So 12 squared plus 16 squared. I would write that down. So L is 20 centimeters. Now all we have to do is plug into the surface area formula. The radius was 12. So everywhere I see R, I'm going to plug in 12. Everywhere I see L, I'm going to plug in 20. And then I'm going to plug it all into the calculator. And I get that my surface area is, see if you were playing along, did you get 1,206.37, blah, 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 blah? So I was going 3 significant figures, 1 significant, 2 significant. That would round up to a 1. So it'd be 1210 centimeters squared for area. Next figure is a prism. Volume, we'd find the area of the base times the height. As the base is, no, the base is this triangle. So for volume, we're going to have to find the area of that triangle times the height of the figure. So the area of that triangle, that's going to be 1/2 base times height. And this is a right triangle, so this could be the base and this can be the height there. But that part's missing. Let's call it, let's call it X. Now, since it is a right triangle, we can go back to that right triangle trig. It is opposite of the angle, and we know the adjacent side is 5.7. So opposite adjacent. That's tangent. Tangent of 42 is opposite over adjacent. Make sure you're in the right mode. Play along at home. You should get that X is 5.13 centimeters. Now, the area of that base is going to be 1/2 the base of the triangle times the height of the triangle. Times the height of the whole prism. So since I already had 5.13 in there, and actually all the way out, I'm going to go ahead and do times 5.7 times 0.5 for the 1/2, and then times 8 that would do it on the outside. This keeps me a little bit more exact because I'm not rounding in the middle of the formula. So I got 117. I don't need the rest of them because that's 3 significant figures, and it was centimeters cubed. Now, for the surface area, let's think about all the places we've got. We've got the 2 triangles, right? The one that was in the front and the one that's in the back. So 2 triangles plus 3 rectangles. 1 rectangle, 2 rectangles, and then the third one's in the back. So we need to list out all of them. Now the 2 triangles are the same exact triangles. So I could do 2 times 1/2 times 5.7 times 5.13, and I'd get each of those 2 triangles. Now let's be really careful here. This was 5.13, right? So I could get the back one. I know its dimensions are 5.13 times 8. I can get the bottom one because this is 8 as well. So it's this one. 5.7 times 8 would give me the bottom one. There's only one that I can't get to. Oh, it's this one, that hypotenuse of that right triangle. So So you have two ways to get there. You could do Pythagorean theorem, or I like the idea of doing some SOHCAHTOA. I know proof positive that my adjacent's correct. I'm trying to find the hypotenuse. That would be cosine. Now, if somebody would be willing in the class to go ahead and do it by Pythagorean theorem, so that way we can kind of check our answers, that'd be awesome. Now remember, over here, I could take 5.7 times tangent 42, but on this side, it's going to be 5.7 divided by cosine of 42. And hopefully, if you did it the other way too, you got 7.67 as well. So this side is 7.67, which means this laying down rectangle is 7.67 by 8. So now all you have to do is add up all your sides. And I got 177.241, which would be 177 centimeters squared. Last example. We've got a pyramid. Now this is going to kind of review the other stuff that we've learned as well. In the diagram below, PQRS is the square base of a solid right pyramid with vertex at V. The sides of the square are 8 centimeters. The height, VG, says is 12. And M is the midpoint of QR. Okay, so good. We got all the information. They've drawn us a picture. Awesome. Write down the length of GM. Remember, when they say write down, they don't expect you to have to do any kind of calculation. If G is in the center of the square, and we're going across here to M, how long has it got to be? Well, it's half of the way, and this whole length is 8, so 4 centimeters. Notice the difference. Calculate the length of VM. So notice where VM is. It's going down the middle of that. If I think about going inside of that triangle, that pyramid, I end up with this little triangle. V goes straight down to G, and it went across to M. We already had what VG was. They gave it to us. If that's the height, that's a right triangle. GM is 4. So it's pretty easy to find VM. 4 squared plus 12 squared equals x squared. 4 squared plus 12 squared gives me 160. And we get that VM, and so I went right back to the name of it, is 12.6 centimeters. Now it says to find the volume of the pyramid. Well, let's go back to our volume formula. It's 1/3 the area of the base. Oh, the base was a square, wasn't it? So that's 8 times 8 times the height of the pyramid. Oh, that's 12. 1/3 times 8 times 8 times 12 gives me, I got 256 centimeters cubed. Surface area of the pyramid. Okay, so now we need to think about breaking that thing apart. So what if I broke it apart and looked at what all I had? I've got these 4 triangles that come off there. Now all 4 triangles are the same. And then we have the base. So it's the base plus 4 triangles. Well, we know the base. That's easy. 8 by 8. Now let's think about those triangles. Gosh, here's the triangle. 8 is the base of that triangle. I wish I knew the height of the triangle, which would actually be this length. Oh, we found it. It was 12.6. We found it right there. VM is 12.6. So the height of the triangle is 12.6. The base of the triangle is 8. So 1/2. Base is 8. Height is 12.6. I listed everything out. 8 times 8 plus 4 times 1/2 times 8 times 12.6. And I got 265.6, which would be 266 centimeters squared. Last one is an area question, an angle question. Find the angle between the face VQR and the base of the pyramid. Oh gosh, the visualization is hard here. VQR, let me see if I can kind of do this in a different color here. VQR is here, right? And we want to find the angle it's making with the base. Isn't that really this angle? Right there? This angle? Right here? It is. So let me draw my picture again. V, M, G, 12, 4. We need to find this angle. I always go back and use the information that was given to me if I can. Well, opposite adjacent, that'd be tangent of some angle equals 12 over 4. So to find the angle, we use the inverse operation. So inverse tangent, 12 divided by 4. And we get 71.565, which would be 71.6 degrees. The rest of this packet is review problems from previous tests and that type of thing. So I would practice through these. Or is it, or did I not give it to you? I may not have given it to you yet. But you will get the review problems. And what I want you to do is work through them on your own first, and then you're going to get a chance to work together on them and compare your answers before the test.